So we're now going to focus on part 2 of our implementation walkthrough of the AsyncTaskBarrier framework, and we're going to show how it's actually implemented. So basically, here's the AsyncTaskBarrier framework. The register and unregister methods are super simple. They just go ahead and add the parameters that are passed into the stasks list. Piece of cake. It's exactly what you'd think they do. And the return type is a mono to void, and that's what's indicating that we're finished when the test is done. The magic in this particular class is in the run tasks method, and this is really super cool. So run tests returns a mono to long that triggers when all the tasks complete. And as you can see here, what it does is it takes the list of tests and it turns them into a flux. So we have a flux of the tests to run. So far, so good. We're then going to use flat map, which will execute asynchronously, because of course these things could be running in the background. And it's going to call the get method on each of the registered tasks, which will then start them in motion, which could be synchronous or asynchronous. Let's assume they're asynchronous, so they're running in the background. We then use onErrorContinue, which will log any exceptions that get thrown by the tasks that we're running and continue. It'll keep running. And then we're going to go ahead and collect everything into a list. And this will actually be a weird list because it's a list of monos to voids. So it's really an empty list, but it's really just there to say when everything is done, then continue on. So it's really just there kind of almost like materialize it, just waiting for things to finish. And then the last thing we do is we return a mono that contains the number of tasks that ran successfully when all the tasks completed. And we do some really funky magic here with the exception handler to count the number of times exceptions occurred and so on and so forth. So it all works very nicely. So that's the end of the walkthrough of this part, but I do want to show you some pieces of the code. So here's the source code for AsyncTaskBarrier. We've already looked at most of this. It has a list of suppliers to monos to voids, register and unregister, add or remove things from the list. And then here's the run tasks method. This is the thing I didn't really show you in detail when I did the quick walkthrough in the slides. This is the magic that we use to keep track of the number of exceptions that occurred. It's really funny, really cool. So we have this atomic long called exception count, which starts out with 0. And we write an error handler, which is a by consumer, which is going to print the thread where the error occurred, the message of the exception, and then it's going to increment the count of exceptions. So whenever an exception is caught, we're going to increment this counter and we're going to log the fact that an exception occurred. And then as you can see down here, we use that as the parameter to onErrorContinue. And that way, whenever an error occurs, this error handler gets called, it logs what happened, and it increments the count of exceptions. That's the key thing. It atomically increments it. And then down here, you can see when everything's done, we're going to return a mono that contains the computation of the number of tasks we tried to run minus the number of exceptions we got. So if we had 6 tasks to run and we got 3 exceptions, then the return result from flat map here will be a mono that will emit an integer that would contain the value 3. Because 6 minus 3 is 3, obviously. And so that's the way we compute this. Rather tricky. It took me a while to figure out exactly how to do this. The fact that onErrorContinue has these weird semantics with onErrorResume made it a little bit more cumbersome than I would like. It's a little bit more obtrusive, but if you're using Project Reactor and you want to be able to do stuff like this, you just have to get accustomed to the fact that if you want exceptions to resume, you've got to tell the exception handling mechanism to stop. Otherwise, onErrorContinue will be the one to get called instead, which we didn't want to have.